usually the first chapter of the psychology textbook or any textbook where they go through the details, like the scientific method and the critical thinking, and everyone skips over that because they just want to get to the juicy details of all the case studies, which is like the Munduruku people and the Himba people and the Maya Lyra. They want to read about all of that, but none of that will ever reach, you will never understand the value of that information until you have the ability to separate bullshit from facts. So are you a critical thinker? Take this quest to find out. So question 1. A researcher debates the potential use of deception. After discussion with her colleagues, there is no alternative methodology to test her idea. In addition, all her colleagues agree that the harm to participants of using deception in her study would strongly outweigh any positive benefits that would be gained. Given this information, which of the following statements is true? The use of deception in the study is not ethically justified, etc., etc. The answer is this one, because she's using deception and it's strongly outweighing any positive benefits. So this study should not go ahead. So in case you're not aware of the double-blind procedure, because I did mention it here, it refers to a procedure in which experimenters and participants are blind to crucial aspects of a study, including the hypothesis, expectations, or most importantly, the assignment of participants to experiment groups. So just have no idea what's going on. The reason that they have this is because they need to make sure that there's no biases or experimenter expectancy effects, as well as placebo or nocebo effects in here. So double-blind procedures are very good. Question 2. Which of the following statements on the differences between experimental and correlational research is false? The answer is C. In experimental research, at least one variable is measured, but in correlational research, all variables are measured. Now, you know that this is definitely the wrong answer, because in correlational research, they just measure two, just X and Y, and that's it. They measure how much they correlate. Question 3. Random assignment controls for important differences between individual participants by either correctly balancing them, holding them constant, randomly sampling them, and this contrasts with designs in which each participant is exposed to each condition or group in an experiment. These latter designs control for individual differences by what? The answer is balancing them and holding them constant. So random assignment, you sort of balance everything out, you smooth things out, and you hold them constant. In this situation where you just have one participant, you don't have different participants, you have this is a good question because it tests your understanding of balancing and constant, because if you imagine balancing physically, you say you've got rocks and you balance them on a seesaw, technically they're being held constant and they're balanced. You could use them interchangeably. But in psychology, random assignment controls for important differences between individual participants by balancing them, in that there's no specific person picked for the duration of the experiment. Everyone has an equal probability of being chosen for the experiment. So the probability is balanced, but the individuals are different for each experiment. Science. I know what I mean. Okay, that's the important thing here. Do you know what I mean? That's the real question. Okay, essentially, let's use an example. What if you wanted to do a study on if phone usage affects driving ability? So you put them in a simulator and you have them in the phone and without the phone. So you're holding the participant constant, right? So you have the same person driving with the phone and you have them driving, without the phone in the simulator. So you're holding the person constant. The only issue there is that the person may feel tired from the previous run, and if you leave it for more than a day, they may be more skilled and more prepared in that simulator. It depends on mood and so on. The person you're testing might just get tired. So even though you're holding them constant, they could get tired. Whereas balancing them, you have a bunch of people do the experiment with the phone, and then you have a separate amount of people do the experiment without the phone in the simulator. And so that would be balancing everything, but you're not holding one person constant. Question 4. A researcher wants to test if juggling improves cognition at a school. Since the girls and boys are disrupting each other, she separates them during the experiment. So the external or internal validity of the experiment has decreased or increased due to which issue? The answer is internal decreased and confounding of variables. So in case you don't know what confounding of variables is or means, it's when the best way to explain this is, yes, in this setting here, but also if you're trying to study how music affects emotions, you can't exactly relate it to one single thing, like the tempo of the music or the beat, what type of instrument is being used, because there's a lot happening at once. You don't know if the tempo is influencing that person's emotions. Is it how loud the music was being played? Those are all confounding variables. And the reason why the internal validity of because of the confounding variables. Good question. So question 5, a young man is interested in making a good impression on the parents of the person he is currently dating. Because of this, when he meets them, he overemphasizes his good qualities and ignores many of his shortcomings. This man's behavior is most relevant to which of the following concepts? The answer is social desirability bias. He is altering his answers, the true meaning of things, in order, to align with societal expectations. We had a look at confounding variables, demand character, never heard of that. But using common sense, it just says something, I don't know. I have no idea what that is. Experiment, expectancy effects. In case you remember at the beginning of the video, I did go through that. Question 6. You studied 2,000 children for a month. Well done. Measuring how much TV they watch and how many violent acts they perform. You find that watching TV and violence are highly and positively correlated. Oh dear. So based on this study, what do you conclude? Well, actually, you can't draw any causal conclusions from the relation between TV watching and violence because correlation does not imply causation at all. In case you haven't, there's this website I should have included in the presentation, but there is a correlation between the amount of cheese people eat and the probability of them dying while being entangled in their bed sheets. That doesn't mean that eating more cheese increases the probability of you dying while tangled in your bed sheets. It just means they're correlated, right? And if you're thinking, okay, well then why do we use correlational studies? Well, if you have a controlled environment, then you can be useful, then you can be, more accurate or more sure that the correlation is due to those two variables. But then we have the bidirectionality problem, which you don't know which variable is causing which. And we also have, a confounding variable, which may be influencing the variables that you're focusing on. So correlation is a slippery slope. So make sure you understand this. Very important tool in the everyday world. Question 7. A clinical psychologist observed an association between parental anger and childhood self-esteem. Parents who score higher on ratings of anger and hostility tend to have children who have lower self-esteem. If our impressions are correct, the relationship between parental anger and childhood self-esteem would be an example of what type of correlation? This would be a negative correlation because as one goes up, the other one goes down. So there you go. If they both went up, it would be a positive correlation. 0 would be just no correlation. Random correlation, that's a made-up word. Confusing. Question 8. Jason is wishing to conduct research to investigate whether having an energy drink at lunchtime causes school children to perform better on in-class activities that afternoon. Like Jason's thinking. He's also keen to test a further hypothesis that this performance boost may be higher for mathematical tasks than for writing tasks. So which of the following would best allow Jason to test his hypothesis? Have a read through. But the answer is this one. An experiment in which his independent variables are energy drink exposure versus non-exposure and task type, and his dependent variable is task performance. Now, see how it says exposure, and I actually went for this answer, but this doesn't necessarily mean that the kids or the participants are going to drink it. So it's not this one. How much they actually drank is what he should be focusing on. The reason this is the independent variable is because this is the variable that is being controlled and changed, and we're measuring how the amount of the exposure affects a certain type of behavior, and this behavior is determined by how much exposure there is. So this would be the dependent variable. Question 9. Jason finds an R value of 0.3. What can he conclude from this experiment? A, B, or C, guys? Well, It's definitely C. There was a weak relationship between energy drink exposure and math abilities. So an R value less than 0.3 is weak, between 0.3 to 0.5 is moderate, and over 0.5 is a strong correlation. If you find yourself with a 0.99, well done. But remember, correlation does not imply causation. Please remember that. Alright, that is the end of the critical thinking presentation. Hopefully you have gained some mental tools to help you while progressing through everyday life and thinking about what the news tells you, as well as studies and what you're actually reading. Thanks for watching.